Welcome. We'll give folks a minute or two to join, and then we'll get started. All right. Greetings, everyone, and welcome to the CHIP Landmark Idea Series. We're talking today about using licensing to maximize innovation in the open source software ecosystem. And we have with us today Karen Copenhaver, who is the legal counsel at the Linux Foundation. I'm Ken Mandel. I direct the Computational Health Informatics program at Boston Children's Hospital. We're a program founded in 1994. Multidisciplinary, applied research and education is our focus. You can learn more about us at chip.org. And this event series features thought leaders across healthcare, informatics, IT, big science, innovation, and more. We've actually had more than one lawyer in our series. If you want to follow along on social media, these are a couple of Twitter handles you can try. And Karen Copenhaver is an intellectual property lawyer who's best known for her work on open source licensing and business models. She's legal counsel to the Linux Foundation, where her guidance is used to support the adoption of Linux and open source technologies inside major corporations. She's a prominent figure in the open source community and has made significant contributions to the field. And the opportunity here to hear and to focus on during this session is to learn about the business models that are supported today. And I think we'll probably talk a bit about how we got there. Open source, when CHIP, our program, started, and we've been committed to open source for 29 years in this program, was a much more novel idea that met with much more skepticism. And that was before you saw, companies breaking into this model like IBM, certainly Linux, and the Linux Foundation, and the businesses that cropped up around it. Microsoft moving into that space. It's much more normalized and also underpins very large business strategies. But it's not obvious how to use the licensing in the most powerful ways, and that's what we're going to hear from Karen about today. So with that, let me get ready to turn it over, and I'll give it to Karen now.
Okay. I'm so honored to be with you today. When I look at the other people who have made presentations for you, I am humbled to be here. But I love this topic. I've lived this topic. I find it fascinating, and I also find it hopeful. So I'm happy to share it with you. I do start from the basics because I've often had conversations where people are thinking about very different levels of collaboration than I'm talking about. So I want to begin with the conversation about the basics, and then Ken and I can have a conversation about other issues when we're. I'm getting messages. I guess I have to do it that way. So I have a pretty audacious goal for the day, which is I want to change assumptions about what is possible. And this is what I talk about. I think people who have been concerned that when I talk about this, I'm sort of naive about how things really work and what corporations are really willing to do, and how these things might be less than practical at a global scale. I want you to begin to think about how these collaborations can work at huge scale across industries and across ecosystems. And that's my goal today. So it's a pretty big one. There are so many ways to tell the story about open source, and I don't want to do a disservice by not telling all of them, but we don't have time to tell all of them. There's a very important story that could be told by Richard Stallman and others about how important the provision of source code is to the provision of really your civil rights as they see it. That the denial of providing source code denies you access to information that is important for you to be able to manage your own data, to fix your software. And Richard has long believed that the decision to not provide source code with software was a huge mistake. And that discussion about freedom and the freedom that his programs and the GPL were designed to protect is fascinating and powerful and important. But that's not the story I'm going to tell you today. I'm going to tell you another story. And this is, of course, I put the elephant up because people can touch different pieces of open source or different parts of the elephant and tell entirely different stories. So I'm going to tell you one particular story today, and it's working now. I want to tell the story of global collaboration to optimize the use of some of the most valuable resources on the planet. And those are the human beings who actually understand how our fundamental systems work. These people, including, I think, many of you on listening to this, have knowledge that helps you to understand the things that are most powerful and most threatening to us. And those human beings who actually understand how those systems work are resources that are valuable to the entire planet. And one story of open source is about how global collaboration can work to make those resources available, particularly in a time of crisis. So it's not a story about what I hope will happen. It's a story about what's already happened. And I'm just going to give you some numbers from the Linux Foundation to give you a picture of this. So, some people think about open source, they think about a couple of guys in a garage eating pizza, writing code over the weekend. These are projects that are collaborations among companies. And these are companies devoting development resources to these collaborative projects. So this is from the 2022 Linux Foundation annual report. In 2022, 827,000 developers contributed, and that was up 12% over the prior year. 17,000 global organizations contributed to an LF software project. So that's all over the world. This is not just the United States. When you go to a Linux Foundation meeting, it will be, as many of your environments are, entirely cross-cultural. I mean, you've got people there from all over the world, and they're all talking code. 52 million lines of code are released every week that are contributed, and that was up 13% over the prior year. $26 billion in development was created. If you just take average global salaries, so this isn't US salaries, but average global salaries, $26 billion in development on these projects. And 3.2 million project builds, which for the developers is a very big number. This is the largest globally distributed engineering workforce in the world that has ever existed by orders of magnitude. And you rely on software that it builds and maintains every day. That's what we're using right now is using Linux and many of the other programs, the communications programs that are built in these collaborative environments. And every corporation and government on earth uses this software as well. So this is not something that I hope will happen. This is what's happening right now. And these things that we've learned in building these environments have application in many other environments. So people wonder, why do companies do this? I had one young woman who was assigned to work at open source at a company, and one of her colleagues that said, well, of course, they always assign the women to the charitable work, as though companies are doing this because it's something that they think is a nice thing to do. Companies don't do things because they think they're nice things to do. They do it because it's enlightened self-interest. And this is where the incentives are structured for corporations to do this. And this is what I call the economics of sharing. So think about, if we go back in time to when we needed basic roads and bridges, we needed infrastructure. And it wasn't necessarily obvious that there were enough resources for everybody to get, the roads and the bridges and the other things that they needed. What we came together to build was that common infrastructure. There was that we had to create standards about how wide mud flaps were. That was litigated for a long time about how wide the mud flaps were on trucks. We created this network because people needed the roads to build their own businesses. So there's a difference between that infrastructure and the unique business differentiators that are valuable. And this was so true and obvious to companies when it came to the operating system. And this is where the learning came from. At the time that IBM adopted Linux, and Ken mentioned IBM's involvement, it had well over 35 operating systems that it was working on. And there was one wonderful man named Irving Waldansky Berger who went in to tell the CEO at IBM all the things that they could do if they could just stop making 37 different operating systems. And the key point he wanted to make is that none of IBM's customers cared about the operating system. What the customers cared about was what was built on top of the operating system. And yet IBM had taken its best and brightest developers and deployed them across 35 plus operating systems. And they are very rare individuals, and this is a very hard thing to do, rather than focusing on a single operating system. And of course, at that time, Microsoft was also relevant in that, that the question was who was going to own the operating system, and IBM certainly wasn't sure that at least on the desktop that they would own the operating system. And the one way to actually compete with Microsoft was to have the entire industry work on a single operating system and to improve it and to use it rather than be entirely dependent upon Microsoft's operating system. And there's it's a fascinating story of the migration until Microsoft also became a part of the Linux story, because they joined the Linux Foundation and joined the patent pledges around Linux a number of years ago, and are now a huge contributor to Linux and a huge beneficiary of these collaborative models that we're talking about. But the story of the operating system was the story of identifying that infrastructure that would be better if it was built together, and differentiating that core infrastructure from what the customers actually cared about, and taking the resources, the highest and best use of those resources, those minds that there were very limited number of people who wrote software then, and to dedicate those people to things that the customers actually cared about. And that's how everybody came to begin focusing on Linux. Companies began to realize the cost savings of shared maintenance. When you have an operating system and everybody is maintaining it, then there's a shared responsibility for security and updates. So we went from a time when open source was a set of raw materials that everybody could use to a set of shared resources that everybody maintained. And this was another big shift in the community. So that instead of saying, well, I'm going to take this software and I'm going to work on it and take it through my product development checklist and make it a product, I want to go back now. I want to go back to the original project and use the code that's being made available from that project. And if I'm going to do that, I need to know that that project is being developed in the way I want it to be developed and is going in the directions I want it to go and I need it to go. And so this turning around and saying, no, we're going to build this together is this part of the story of Linux. If you look at the cost of developing something like an operating system in-house and having only your developers work on it versus an external shared development, there's an enormous cost savings in developing this kind of infrastructure in this way. There's also just a recognition of how rare these resources are. There are not thousands of people available who are qualified to write operating systems, to maintain operating systems, to do that work. They're not easy to find. And everybody wants to hire the best and the brightest of them. So this open source development is the way those people want to work on software. And it became a very important part of an HR's message to developers as to why you should come work at a company, because they are actively involved in the Linux community building out Linux. Another part of this is really a recognition of vulnerability and dependencies. When I started practice back in 1979, every company wanted to be an island. They wanted to control things from the chemicals all the way through to the product. And many of the things that we did and many of the agreements that we wrote were based on this assumption that we owned our own destiny. Along the way, it became clear that companies became a whole nest of contracts and relationships and dependencies on other companies, that nobody could cut themselves off on an island and succeed. That network of dependencies and that vulnerability was something that needed to be understood and acted on. And boy, we learned this big time during the pandemic when everybody started talking about supply chains. So this method of collaboration is a way of recognizing and managing those vulnerabilities and dependencies, looking at them straight on and figuring out how we're going to work together. And the economics come from the fact that the speed of innovation in these environments and the opportunities that come with participation outweighed all the naysayer concerns. And there were always naysayer concerns. There were always people that said, this will never work. We don't know where this code comes from. There were many things that particularly the lawyers, I have to say, who thought that this was never going to take off. And it all happened. And it all happened actually much more quickly than people expected. But I want to make this point so clear that the companies are doing this out of enlightened self-interest, that you can build communities around incentives that make them want to do these things. And it turns out that they're the right things to do. So how did you build an architecture of participation? And that's one of my favorite phrases. It comes from Tim O'Reilly very early in the open source journey, was that he said, building an architecture of participation is building a framework that brings people together and makes them successful in their efforts. And it's a non-trivial task to build that architecture of participation. But I have to say that the fundamental in an architecture of participation is establishing trust. Nobody wants to participate in the community if they think that they are going to get snookered down the road because somebody else is benefiting more than they will. So you have to be able to build an architecture of participation that gives everyone trust in that collaborative environment. So you need to bake in neutrality and full transparency. And one of the ways that we've learned to do this, and this is the licensing aspect of it, is to use a well-established open source license with broad adoption. Are these licenses perfect? They are not. When lawyers read them, they come up with a million reasons why they should be modified, they should be changed, and they are not changed. They are community assets as they are. They're artifacts of the process that we've gone through. Everybody knows what the Apache license says. It's a very valuable license. When you go to a lawyer's office in one of these companies that does a lot of open source and you say that there's a project and it's under Apache, they know what that means. If you change 3 words in the Apache license, and they could be wonderful improvements, but if you change those 3 words and it's not the standard license, everybody stops because they fear that somebody made that change because they are going to be advantaged by that change in some way that the community doesn't necessarily understand. The use of these licenses, as imperfect as they are, is a part of establishing instantaneously this neutrality and broad fairness in the environment. So you have to bake in that neutrality. The full transparency is another thing that confuses people because we all know that we've signed more NDAs than we could, wallpaper all our houses and corporations with. And everybody signs an NDA. Everything is confidential. You don't know exactly what's confidential, but you got to sign the NDA. Everybody signs the NDA. You don't sign NDAs in open source. And nobody has an obligation to keep something secret. And when you think about the development and the developers from all these different companies coming together, you realize that that is absolutely essential. Think about something that you learned a number of years ago. And if somebody had told you that you could not use that idea for some reason, would you have been able to trace everything that you've done since then back to say, yes, I did all that and I didn't use that piece of information I got all those years ago? That whole concept of limiting developers' use of information it makes no sense in these open environments. The information is available to everybody at the same time, at the same rate, at full transparency. Anybody can take a look at it. And that's a feature in these communities, that there is absolutely no secrecy. And that's part of what builds that trust into the collaboration, because if you ever wanted to go look at what was going on, you have access to everything automatically all the time. Avoiding the negotiation of custom documents. These projects that we launch, we used to take, maybe a couple of months in getting people at different companies lined up to put the resources together to launch a project. And we'd have, everybody would take a look at the documentation and we'd have discussions and we'd have to explain various things about various licenses. These projects are now launched in a matter of days or hours. Once you have the technical specs for what people want to develop, the project is started and launched, and there are people working on it instantaneously. If you came in with a set of custom documents and said, well, we want to do this a little bit different, let's look at this, you would just be thrown out of the room, because the idea of negotiating separate terms for each relationship means that somebody possibly is being advantaged by those special terms. So the use of these, I'll say, imperfect open source licenses and some very standard documentation around governance that establishes a complete limitation of liability for the companies involved is what enables these things to happen so rapidly. And this limitation of liability is something you'll potentially be reading about in the press, because there's a suit in the UK right now. Came out of all the Bitcoin kerfuffle, which is talking about establishing that there should be a liability on everybody who contributes to an open source project. It would be disastrous. Why? Because again, if you go back up to our economics and the economics of sharing, these are based on the idea that the full limitation of liabilities in those open source licenses work, and that the companies don't have to take a step back and say, well, I don't really want to participate in this because I have to think of what the downsides are. The limitations of liability are part of what bring the companies into these projects, and they're important, a very important element of the environment. So you get a formalized system of open governance so people know how they're going to work together, and you use documentation that everybody's familiar with, and you've established a very deep set of trust among people all around the world. And I'll say that the use of these standard documents is even more important if you're looking for global participation. If you change language in one of these standard documents, it has to be translated into every language in every country where people are participating. If you use the same documentation that everybody has used everywhere else, they also know what that documentation means. They translated it years ago. They've got a kind of understanding. They know that this is what everybody uses. They know that everybody in the United States that's using this license is going to have the same terms as they'll have. It's in a global environment, the non-negotiation of these documents is even more important. And then there's another piece that is, I think, often ignored because we talk so much about the lawyers and we don't talk enough about the developers that do the work. And you have to establish what we call the duocracy. The decision-making is in the hands of people who do the work and understand the technology. I'll tell you a story that I think makes this point so clear. There was a developer that worked, was working at a company doing software development during the day and was working on Linux at night. And he said, somebody asked him, why would he do that? Why would you go work on the software at night if you work all day? And he said, well, you see, I have a different impression about what if this doesn't make sense. So I work at a software company all day, and I have people tell me that we have to release software that isn't finished because there's a trade show next week. And so we put buggy software out there and we convince everybody that buggy software is the norm. And I'm told to do things that I know that the technology doesn't actually do, because some marketing person came up with an idea and said, oh, we ought to do this. And I come in and I say, but that's not the way it works. So, oh, no, they'd love that. I said, yeah, but it's not the way it works. Oh, no, we're going to release that next Tuesday. So that's what I do during the day. And then at night, I get to work on a project where we don't release software until it's ready, where we're incredibly proud of the work that we do. We work with other programmers whose opinion we value, and we release software only when it's ready. So which of those doesn't make sense to you? The open source world is you're putting the development in the hands of the people who understand the technology. And I cannot overstate how important that is in the way these communities work and why they are successful. As they like to tell me, they have no time for marketing. They have no time for anything but the truth. They are blunt and direct, but they write elegant code that they're proud of and that they support and commit to for decades. So how could this story possibly be relevant to you? Well, among the most valuable resources on the planet, as I said, are the human beings who know how our interdependent systems work. And many of those individuals work inside corporations and institutions. And those corporations and institutions are not always ready to make those resources available in the event of an emergency. Their first reaction is a fear of liability. And there's no articulated business case for their involvement. I want to give you an example of this, which makes me sad every time I think of it. I was reading a Scientific American article on the deep water horizon, and they were talking about this this problem that there were only a few vendors that were involved in the problem, and nobody trusted them. When they came up with their plans for what they wanted to do, they were the ones that built it. Do we really trust them? The government came in. Nobody in the government had any idea what a deep water well looked like or should look like or how to fix it. And the article made this one point. They said, the other companies, the other vendors that might have known how to help, that might have been able to say, yes, this plan worked. that might have been able to speed that process along, they all stepped back. They didn't step forward, they stepped back. And if you remember, the oil spewed forth for months. The expertise was not in the government, it was in those other companies, and those other companies had no idea how they could get involved and to make the people available that actually knew how those wells worked. And how many people do you think in the world actually would know how that well worked and what might be appropriate? I mean, maybe in the hundreds, maybe, probably not even that many, but those people were locked away. So what I want to suggest to you is that this ecosystem of corporate collaboration that builds the software infrastructure that powers the globe is an example of how to build an architecture of participation to enable the sharing of these resources. And I can think of so many other places in in our world where the people who understand how that system interacts with another system, that they number in the 20s. But to get them involved in a way that you would have to negotiate with every company in order to get them comfortable that they could make them available, that you negotiate some limitation of liability, that you negotiate some trade secret agreement, that you negotiate all these different terms, the oil would spill forth for months on end. So I want you to think about how it might be possible to take these concepts and to build out other collaborative environments and to begin that process of building architectures of participation and to learn these processes so that they're available to us when we actually need them. And Ken, that's what I have on the slides, but I am happy to talk with you about some of the things that you wanted to cover. And I'll stop sharing right now. And Ken, I think you're on mute.
Here we go. How about now?
Yeah, good.
I'm very intrigued by the way you transpose this into, it's not a perfect analogy, but let's say the physical world with the Deepwater Horizon example. And there's a question from Adele Stewart where she asks, are there similar systems of open governance that we see? Are there some examples of this type of collaborative governance that has an analog to the open source principles of contribution that you can point to? Are there any sort of nascent or developed examples of this?
Well, I think the best long-term developed example would be standards bodies. And there's a lot of learning there. But when I spend a lot of time talking about standards and standards bodies, they were formed much more around patents and understanding patents than they were around this kind of instantaneous collaboration. It's a different system, but certainly there's a lot to learn from the way those standards organizations have worked for years and the way they're evolving. So the Linux Foundation has become probably one of the largest standards bodies on earth in just a matter of years because they have adopted this open collaboration method around standardization. And corporations are realizing that that the way you convene on the software side works in some ways for standards. The open source licenses don't work well for standards because the specification is very different than software. But the method of coming together, the consistency of the terms, the ability of developers to almost instantaneously form a well-defined community around a standard that is necessary, that all of that has been, has been an important part of the learning. And I'm sure that you're involved in many communities that have collaboration. I mean, I going back all the way to when you worked on I2B2, there a massive story could be told about collaboration. So I do think that there are examples. I think many of them have the legacy of negotiations around trade secrets and intellectual property, which is why we're talking about licensing, that that give those concerns priority over everything else. That if you don't work out all the intellectual property, you can't get started on anything. And it can. We used to do a development agreement. I remember when I first went to IBM in 1979, 80. We did an agreement. It was 460 pages long. It was for the development of a semiconductor, and it was with a company in Europe. And we worked out everything. I mean, the staffing plan, every little detail was worked out in advance. And when we finally got to the point that we signed the agreement and started all the work, the developers looked at the specifications that we had been working on for all those months while we did all of those developments, and none of them were relevant anymore. Because we had worked so long in the agreement that the specs were wrong. Well, now, that kind of irrelevancy is instantaneous, because if you begin developing something and you say you know what it's going to look like when you're done, well, then you're obviously too late because somebody else has already developed it. So the idea that you can't stop and write down, here's what we're going to do, and that you're going to use these existing methods of collaborating is just consistent with the time frame of development now, and how fast that moves. So that's a long answer to say I think there are existing things, and we need to existing places where this happens. I just think that we have to take the current time horizons, and we have to take the priorities and shift them a little bit. Because whereas it used to be, the big concern was, about protecting your intellectual property. In some fields, that's still going to be, primary. In the software world, the idea that I'm going to not move forward because I'm going to worry about whether or not I've licensed something, you've missed your window of opportunity. And I've often said that the open source was the one permanent beneficiary of the tech bubble. Because in the tech bubble, the risk, the whole concept of risk shifted. So before the tech bubble, the idea of open source being, oh, but do you really know what that is? And do we know where we know what these things are? There were all these worries and concerns. And then the tech bubble came, and the biggest risk was missing the window of opportunity. That was the biggest risk. So all of those other concerns became non-existent almost in the light of how fast people needed to move, and that they needed to use these available resources because everybody else was using them. That never ended. That was the one thing from the tech bubble that never ended, is that idea that I can't move fast enough if I don't use these available resources. So, long answer.
How does the impact of level of difficulty at patenting algorithms, for example, factor into this open source ecosystem? So, vis-a-vis the trade-off between trade secrets and open source and moving fast and not leaving opportunities behind. In other words, as we see areas where it may be difficult to patent certain software, and it may be difficult to patent certain algorithms, and then there's the openness of open source versus not unpatented but secret code. There's this sort of mix of opportunities and directions that one can go in. And how, where's the balance around that now? Let's talk about, for example, something that many folks in our program are interested in, and that is developing novel machine learning applications for healthcare. And so this relates to everything from predictive algorithms to reading X-rays to clinical decision support. And we see many models out there. What about the sort of current environment, current laws, current trends is you think going to shape that? Wait, I think we lost your sound a little bit.
Did you?
There
Okay.
it's back.
I might have just turned my head. Okay, back. So it's a big question. I have to take a step back to where software began to sort of make sense about this. So this is specific to software, and it might not be specific to some of the things you were talking about, but I'm going to talk about software in terms of the algorithms. So, until 1967, IBM gave away the software with the machines. They were the only they were the only ones writing it. In 1967, the Justice Department sued IBM, and there were many, many claims. But one of the claims was that combining the software and the hardware was tying and was a violation of the antitrust laws. And when IBM looked at all of the claims that had been asserted against them, one of the ones that they thought was problematic was that eventually, maybe not then, maybe they didn't agree that at that point in time they were really separate products, but eventually hardware and software would be separate products. And so they did something called unbundling, where they unbundled the software from the hardware. The reason that this is relevant to what you were just talking about was because up until that moment, nobody cared what the intellectual property scheme was for software, because IBM gave it to you with your machine. They sent in the person in the navy blue suit to fix your machine. The minute that they unbundled and created a separately priced product for software, the software industry was born. And the idea that there had to be intellectual property protection for software was presented as sort of like a clean slate. Where do we go? Where do we go? Well, the one thing everybody knew at that time, or thought they knew at that time, was that software wasn't patentable, that it was math, it was algorithms. There were cases that said it was not patentable. So if you look at all the different forms of intellectual property that are available, you take patent off, and of course, trademark's always relevant, but not really protecting the innovation. The only thing left was trade secret and copyright. And it wasn't clear at all to anybody that code was copyrightable. So they started a whole plan of the CON2 conference, the Conference on New Technological Uses of the Copyright Act, to figure out whether code was copyrighted. And Jack Brown and Apple litigated whether object code was copyrightable and source code was copyrightable, all of those kinds of things. And IBM was behind this, really trying to protect their business model, which was they thought all the money was in hardware. What they didn't want was for people to come in and be able to control their customers by having some control over the software that was being delivered. So they were pushing for copyright protection of software as a sort of light protection. And this was the idea. We were just talking about Richard Stallman. This was where it came, where they said, okay, what we're going to do is we're going to make this the source code secret. We're not going to deliver the source code, and the protection is really going to come from the fact that you won't have access to the source code, and only we will be able to support your code because we're the only ones that have access to the source code. And this is where Richard Stallman, who's the father of brilliant programmer, this is why he stepped in and said, no, you have to give me the source code. I can't fix your stuff if you don't give me the source code. I have a right to your source code. And people think that he's, a little outrageous about, by pushing through all these years, you have to give me the source code. He grew up in a world where he had source code. So the secrecy of source code was important. There was a period of time where some companies were claiming that the screenshots were trade secrets and that you couldn't show the screenshots to anybody else. I think that the way the world has evolved with open source is that this concept of secrecy has just eroded to the point that you realize that your customers want the functionality. They don't even want the code. They don't want the source code. They don't know what to do with it either. But the idea that I'm going to protect everything as a secret and that I'm not going to let anybody else access or work with my code falls away as everything becomes interoperable. I mean, it's no longer just interfaces. Everything has to be integrated into a whole. So if you look at intellectual property, you've got patents, you've got copyrights, you've got trade secrets, and the copyright protection has evolved in many ways, which we could talk about for a whole day, but is is much less problematic. People don't. There's been very little copyright litigation, much less problematic. The secrecy has been eroded enormously, and then there's this rise of whether or not software is patentable or not patentable. And I have to say, in my estimation, that has been a wonderful thing for the lawyers, and it's been a terrible thing for the industry. It might have been fine for the industry if the rules were really clear from the beginning, but they weren't. And the beneficiary of a lot of this is that all of those patents are now being bought up by private equity interests that are funding the litigation that is going to drive everybody crazy. And if you go to the Unified Patent site, they have reports on the amount of money from private equity that has gone into these litigation shops. And here's the problem with a lot of the software patents and the algorithms is that there might have been 50 ways to do something, but there was one way that became the way to do it. You might have been able to do it all those other ways just fine. The person who has the patent on that way that it's actually been done has enormous leverage. And there have been situations where entire code bases have been rewritten just to avoid a patent claim. So again, if we're talking about infrastructure versus differentiators, it's sort of a, maybe I could talk differently about filing patents on those differentiators. But once you move beyond just the software and just the algorithm to practical applications, I think your patents really look very different because you're looking at what the actual innovation is in the development and not just in the way the software actually works with the hardware. I'm going to put my glasses on because I see a lot of questions.
So let me take this one from Monica Jang from our intellectual property office here. I love this concept of duocracy. How do you suggest we move such a mission forward in a highly administrative institution such as an HMS affiliated hospital?
Well, we should have lunch because I would tell you, I could tell you a lot of things, and this is going to seem like it's off topic, but it's not. When you're talking about making technical decisions, there are people in the room who are very quiet, who are thinking. There are people who have operating systems that run in their brain. I mean, they can run an operating system in their brain. And when you come up with a question about the development process, they're off in their brain thinking about how all of that actually operates. And in our normal environments, the meeting has moved on, and 15 people who have no idea how an operating system works have taken the conversation into 50 different directions. So there is a way of building a system, and in software, most of it is that you don't have a lot of in-person meetings. you really, you write it and then it gets reviewed. You don't say, well, why don't we do this? You write the code that does that and then it gets reviewed. There's a way of communicating around the development that doesn't give somebody who talks faster and is more glib and is more powerful at the table primacy. It's a very interesting process. But I think, I think they have a phrase, code first. Give me the code. Let's not talk about something that doesn't actually work. Let's look at the code. Let's actually develop it. And maybe it'll be messy. It doesn't have to be finalized, but let's look at something real before we have another conversation and another PowerPoint and another meeting about where things are going to go. And as fast as development goes, that actually works.
That's a great answer.
But if somebody wants to, I can talk to you about how these meetings work. But
that we'll probably take you up on that. I'm sure we will. Here's a question from Gregana Savova asking if you could dig in a little bit more on that Coinbase or one of the lawsuit that you mentioned, possible consequences to the open source community.
Yeah, there are people that are very worried about the tool trading case, believe it or not, is the name of the case. And it's not the first. It's not the first case like this, but it's got a lot of money behind it. And again, it's who's funding this litigation and who's going to benefit from it that is scary. There's been so little litigation in and around open source. We had the SCO lawsuit years ago that we were incredibly successful on. We've had a couple of other patent claims, but so the idea is that you do have individual developers that are and frequently they are among the best developers on earth in whatever it is that they're working on, and they do that with the idea that they're not going to have this liability because they can't pay for lawyers. They're not getting paid for a lot of what they do. They might be paid consulting fees because they work on things. But this idea that I'm making something available without charge and that I may end up answering in litigation about this. I'm making these resources available to you. If you want to spend more time, checking them, if you want to do more review of the development, if you want, whatever you want to do is fine. I'm making a resource available to you that you can do whatever you want with. You can modify it. You can use it in any way you want. So that concept of not being responsible, in a way was important to those developers. It's even more important to the corporations, because if you go to the corporations and say you're working on this project and there are all these little companies and they're big companies and you're the biggest company and now you're going to be responsible for everything that is contributed to this project, I think many projects will just shut down because everybody will run off and try to think of how many parade of horribles could happen and things. So I think that those the way that the disclaimers have worked historically is not a small thing. They have not been challenged, so we don't talk about them very much, but it is not a small thing. And if this tool trading case says, oh, everybody's responsible for all the code they write, the sharing could come to an end very quickly, and it would be a tragedy. So I am worried about it. I have seen so many cases that look like they were going to be problematic, and they end up resolving themselves in ways that make sense. Hopefully, the judges pay enough time to figure out what actually makes sense. But there is a certain, for someone who doesn't understand the environment, there, you can see how they could end up saying, no, everybody's responsible for everything that they do. And everybody should be responsible for everything that they do. Your name is on it. You are responsible. But what you're putting on top of it is a whole system of litigation that isn't really about anything other than leveraging negotiations for settlement payments. And that's that can't happen.
So fingers crossed. Here's a question from Bill Acava from CHIP, machine learning expert. And this is an inside baseball question, how important is it for software licenses to be share alike? Do you think Linux would have been as successful if the open source licenses, for example, the MIT license, allowed derivative work to close source?
I think that's a great question, actually. I will tell you that the Linux kernel developers, adopted GPL2 as really the constitution for their community, and they did have a different understanding of exactly what GPL2 required, which came out when we went to GPL3, and there was a big discussion about whether the Linux community would move to GPL3 or GPL2, and I say that saying I think it's very important. I think for that community, I think it's very important. What moved in the Linux community, so this would, I'm sure Richard would have enormous arguments with me on this, but in the Linux community, you moved very quickly to the point where people wanted to consume the code from the project. This is what we call, upstream contributions. So whereas, open source in the beginning, of course, Richard wrote these unbelievable tools, just incredibly valuable tools. There was no one on earth writing software that wasn't using something that Richard Stallman wrote, including the GCC compiler. But in the early days, the open source projects were made available as though they were raw materials. That you can use this, you can take this code, you can do whatever you want with it, and these the code was the modification rights were important, etc. What has happened is that the code is no longer raw material that you go build something else. The code is available as made available by the project in the form in which it is going to be used. And everybody wants to draw from that original project the code that they actually want to use. And why? Why would that be the case? Why wouldn't you want to modify it? Because you lose the economic benefits of the project. That shared maintenance, that ability to come up with security patches and apply them instantaneously. As soon as you've got some modified Linux kernel, you can't consume all that maintenance. I mean, you've now taken on the burden of maintaining it. So the idea that you're going to make a modification and not share it back with the community makes absolutely no sense from an economic point of view. Richard was concerned about freedom, and I understand why he was, and he could tell you a very important story. I would tell you that the incentives now are for you to upstream your modifications, and it doesn't have anything to do with the license anymore. It has to do with the economics of sharing and not taking on a separate fork that takes you out of that circle of benefit. Now, when you look at the Linux Foundation projects now that are not Linux, we started out with Linux, and then we had the first one was something called Open Daylight, which was a network virtualization, and that first non-Linux project took a long time for people to come together and figure out exactly how they wanted to do it. But what they wanted to do was they wanted to build this new thing, and they wanted to build it like Linux. That's what they want. They said, look at this magic over here that happens with the Linux kernel developers. We want to build this like Linux. And all these other projects, which there are thousands of them now, why people come to the Linux Foundation is they want to build this the way the Linux kernel developers built Linux. But they no longer feel like they need the GPL licenses to do that. Most of the projects at the Linux Foundation are under Apache or MIT, and because of that economics, because of that natural incentive to make contributions, they no longer feel that they need the legal construct of the license. Once again, the licenses are about the lawyers. The lawyers don't do anything. This should be a discussion about the developers. and about the incentives that the developers have to do this. So, I cannot overstate the importance of Richard Stallman in the history of software and as setting out, the goals here. Unbelievable. I honor him. We would never have gotten here without him. But in some ways, these corporate things have moved beyond what his original interests were.
So enormous benefit to shared code base. Here's a question that gets us into the medical software area from Simon Warfield, and it sounds to me like it almost harkens back a little to the original IBM. We're giving you the device and the software because only we can fix it. What are the implications? There's a lot of medical devices that have proprietary closed source software that's associated with them, and the FDA is working on a regulatory framework for software as a medical device, which is emerging, and I've observed that it's very often not open source. To the extent that we really may not actually even have a very good idea of exactly what the device is doing under various edge cases, for example, given the limited amount of information, given the limited amount of testing that's required to get the approval in the first place. Are there lessons learned, let's say, for the regulatory agencies from the open source community?
Yeah, I tell you, Karen Sandler has a pacemaker in her body that has software in it. She's a free software, has been working on free software, particularly Richard's kind of free software for her whole life, and she has a wonderful presentation that she has many of them, but you can find her on the web, and she can talk about the fact that that when she went and asked if she could see the source code for the device that would be implanted in her body and the reaction that she got. The FDA at that time had very few software people on its staff, and then, as you know, we've had situations where people have been able to reprogram devices across the room because the people at the medical device companies didn't have a lot of experience with radio technology. So I think what I would say, there are a couple of pieces. One of the things that the FDA is working on, and I think this is sort of the basic, let's just start with the basics, is this, they call them SBOMs, software bill of materials. And so from a very basic start, whether it's proprietary or not proprietary, you got to know what's in there, and this is something that everybody ought to be focused on. So, and I'll go back to the Equifax disaster, which I know is not a healthcare one, but let's not talk about if just money, it's easier to even think about. So there was a particular Apache code. Apache is a whole project. There's all kinds of code under Apache. But when the Equifax problem came up, there was a particular project from Apache that had been patched for years. But there was a security patch, but it wasn't patched downstream, people who were using it. And then there was the Equifax problem, and everybody knew that this software ought to be patched. So you would think that everybody would patch that software, right? You can go find studies, I think it was 7 years, after whatever that time period was after Equifax. I think it was 40% of corporations had never patched that software because they didn't know they were running it. And there's, all over the place, there's hundreds and hundreds of instances of different software, and but they don't know they're running it. And so when you're talking about proprietary software, I don't really care so much about the licensing model. That proprietary software is 80% open source. Whether they're making it available to you as proprietary or not, 80% of what's in there is open source. And then there's another 20% of their software which may need to be patched as well, because I do not want to indicate that open source is has more security problems than proprietary software. That is absolutely not the case. But there's this mix of software, and there are known security patches, and they aren't being installed. So let's just start with the basics and say, if somebody is giving you a medical device, and they can't tell you what software is in there or whether that software has been patched up to the current level, let's just start there. Let's just start there. Whether that software is proprietary or not, whether they want to keep the source code secret or whether they don't want to keep the source code secret, I think every discussion about software right now is about security. What are they doing to address security? And whether they want to share that intellectual property or not is mildly interesting. Whether they're actually maintaining the security of their software, that's very interesting. And remember, what you've got at a company working on proprietary software is you've got a small handful of people who have access to that source code. You are completely and totally dependent on that small handful of people to do whatever is necessary to make that software work and to make sure it's secure. You're in the open source world. Everybody can see that code. Everybody can look at it. Everybody can run security tests on it. But you're relying on that small group of people that have access to that code, because that's how they keep it proprietary, is that they're the only ones that have access. That's fine. Tell me what you're doing to make sure that that code is secure.
Great advice. So, Karen, we're just coming up on the end of our conversation. This has been fantastic, as you can see from the level of enthusiasm you've generated in the Q&A in the chat. It really is very inspiring to hear about the way the Linux ecosystem has proven itself to be a very efficient set of tools and processes and software for so much of the corporate world, based on these principles of duocracy and and a shared and reliable code base and reliable licensing that doesn't require excessive legal processes on top of it every time we take one step forward. And I think healthcare does have a lot to learn from this. I thought Monica took us in a great direction about how we apply the duocracy here as well, and that was inspiring too. So I hope we do get to keep this conversation going, and I really want to thank you so much for spending some time with us this afternoon.
You're very, very welcome. And Godspeed. You guys do the work of angels.
Thank you. And I'm going to just let us know about some upcoming talks in the series, one in a month with Alex Wilchko, who is the CEO of Osmo, an amazingly interesting new company spun out of Google research that digitizes scent and is really, really a wild story. I encourage you to come. Robert Langer then will kick us back off after a summer break. He's the most cited engineer in history. Ian Lipkin then, who's a renowned virus hunter at Columbia. Rick Burke, who co-founded and is the executive editor of STAT, a stunningly successful healthcare and biotech publication out of the Boston Globe. Tom Mayer, who was the medical director at the NFL Players Association, who over the last 7 or 8 years has just dramatically changed the safety for NFL players through a variety of interventions and studies and political pressures. And you'll see that the NFL and the NFL Players Association form a very interesting microcosm of the larger healthcare system. Molly Ann Brody, who you may not know her name, but you've certainly seen her research. It's very common that when you see a statistic in a news article about public opinion about healthcare, that it comes from the Kaiser Family Foundation under Molly Ann's leadership. Toby Cosgrove, who's a storied CEO of the Cleveland Clinic, will talk to us about about his experiences in leadership, and Chrissy Farr, former CNBC health tech reporter, will be speaking to us soon. So thank you all for joining, and we'll see you next month on June 16th.